All right, welcome back. If you're just joining us, this is part three of 6 talks relating to procedural generation. Because these are half-hour talks and I'm hitting all kinds of topics, if you've already been here, you've realized they're somewhat elementary, but I'm trying to cover as many of the useful tidbits that I use all the time, that I love and have learned over the years. So this talk is going to be slightly different than that. This is a little bit apologetic in the apologia sense of trying to make a case for let's stop generating things this old way and let's start generating things this new way. And it's not profound, but I think for me it has profound effects, much like a lot of these. So I call this staged parametric map generation. Yes. All right. So once again, I'm going to start with motivations and then cover what I mean by mutators, not generators. That's my main premise here. And then I'm going to go through a bunch of examples, probably a painful amount to some of you. But if you haven't used any of these techniques, then they will be an introduction for you. And if you have used them, you might see some new twists on them. But mostly, it's important to see them used in concert together, which I'll explain. So motivations. There are lots of tutorials on how to make map generators, some really good ones. For me, many of them suffer from the same flaws. Very few ways to give human control. That's kind of one of the things we were talking a little bit about in the last talk. But that's definitely a theme of this talk as well. Very few ways to combine techniques, right? You might have a cellular automata dungeon generator or a Perlin noise dungeon generator. Like, do you have both? Can you have both? Can you mix those with other things? So combining techniques for combinatoric successes. And finding more ways to create a wider variety of things. And I'm using map generation as my example in this, but that doesn't have to be the only, that's just the example that I've picked. Okay, so parametric design. The basic idea of that is that we want to give the humans control as much as they want and no more and no less, right? So we want to give the human the ability to say, I don't know, just fill this part in, or no, I want to handle that part explicitly, or I want this to be done in these 3 steps in this particular order. But also, the flip side of that is try not to make them do too much dirty work. Just let them be able to do a lot with very little. For me, being a data-driven advocate, I think any knob that the algorithm can play with should be exposed, ideally. And if that knob is not obvious to a non-programming designer, try to find a way to make it obvious. A bad example might be you're using radians, but don't make them type in 3.14, right? Have them type degrees or show degrees on the screen. But there are a lot of other ways, like give them a color picker, that sort of thing. And then mostly, the more we start adding these knobs, it's very easy to overwhelm designers. Like, what does Perlin octave persistence mean? Just make it default to something reasonable so that if they don't know about it, they don't care about it, they don't want to deal with it, it's good, right? That's the idea. And the idea is that the human is still authoring, but more abstractly, right? More indirectly. All right, so the general premise that I'm trying to advocate is let's use mutators, not generators. So the big idea is let's not generate maps using an algorithm or whatever you're generating. Let's generate it in several stages. So the human authors define types of things to generate. They say this is how villages generate, this is how cities generate, this is how dungeons generate, this is how temples generate. And the humans explain that, but they explain how it's generated by just saying, first we do this, then we do this, then we do this. So the humans decide which steps to run and can tweak all the knobs for each of the steps. And if the knobs are the right knobs and they're exposed powerfully enough and they're intuitive enough, even just within a given generation step or a mutation step, you can have dramatically different effects, which we'll see. All right, so most of the time I want to spend on this talk, again, I'm not sure how long we'll run, is by just going through kind of one mega example, start to finish. And I just came up with this example as just an idea of showing off some of the kinds of mutators I want to give. So the context here is a simple 2D roguelike tile-based level, but as you'll see later when we talk about the digging with Perlin worms and the infinite worlds, we can use some of these things in 3D or with other data structures too. So there's lots of possibilities, just to name a few. So I'd say start with the simplest one, which I'll call replacement. Then we'll look at cellular automata, and this isn't just going to be the Conway's game of life, your father's cellular automata. I think there's more fun we can have with it. Rooms and paths, they can be very specific, though that can be used to make everything from farms to caverns to town halls to palaces. Content injection, we mentioned before. I want to be able to just say, oh, at this stage, I want you to load this file, and then I want you to do something to that loaded file, and then I want you to do more stuff and more stuff. We may want to use Perlin noise and some other stuff. All right, so hopefully you can read that. If not, I'm sorry. So this is a simple map definition, probably the simplest one I can make in this simple system that I built for this talk. So this is a map definition called test. Yes, I am a programmer. And it's going to make a map that's 64 by 36, though I could easily have that be integer ranges like we talked about before, or omitted entirely, and it has to be provided by the person invoking it. By default, this map's going to be filled with grass, and it has a visibility distance of 100, as opposed to like, a deep, dark dungeon where you may have less visibility. And you're going to start on some tile that is grass. So it'll randomly pick a grass tile, which is going to be all of them, and start you on it. So there you go. There is our first map. All right, so the first mutator that we're doing is the replace mutator. So super simple. The rule is replace. If it's grass, change it to dirt. That's it. So replace if type grass, change to dirt right here. And I run that, and great, it replaced all the grass with dirt. So probably what I want to do is be able to say, oh, well, wait, don't always do it. Only 60% chance of doing it, something like that. So now I add a new attribute. Chance per tile is 20%, so it's going to, for each of the grass tiles, change it to dirt, 20% chance. All right, now we get something like this. All right, so let me add a few more steps. There's a 20% chance for each grass to change to dirt. There's a 10% chance for it to change to sand. And there's a 40% chance for it to change to shallow water. So now we get something like this. Right? Not very interesting so far. All right, so let's go back for a minute, because I want to start building something more deliberate now. So let's clean the slate, and we're just going to say, if you are grass, there's a 1% chance that you'll change to water. So now we're going to get a few little scattered droplets of water. All right, so let's add our second mutator, cellular automata. Who is familiar with cellular automata? Okay, about half. Cellular automata is the idea of you can, and there are different ways to frame it. You can do things to your neighbor, but I like to think of it as I will change if my neighbors are blank, right? So in this case, I'm saying if I am grass and my neighbor's is dirt, then I'm going to change to dirt. Now, if that's all I'm saying, then I'm assuming that that means what? If I'm touching any dirt at all, then I become dirt. So dirt is contagious. Oh, but in this case, the actual line I'm going to put in is, if I'm grass and I'm touching water, then I'm water. So now the water is contagious. So now all these water droplets spread into 3 by 3 blotches of water instead of 1 by 1 blotches of water, right? That still feels very robotic. So, but I can add chance per tile, 50%, just like I added to this other one. In fact, chance per tile is something that I have on all my mutators. So that whatever they're going to do, there's a chance they won't, whatever it is. And we'll talk about that in the final talk, tagging things and creating heat maps. They can opt out. So 50% chance, if I'm grass and I'm touching water, to become water. Now I get slightly more organic looking water, right? excuse me. Well, I can do, pardon me, I can do several passes on this, right? I can say if I'm grass and I'm touching water, there's a 50% chance to change to water. I can do it 3 times. I just copy paste to the line. So now each water 3 times we'll go through the map and we'll have a chance to do this update. Now there's something I need to stop and say that's important about cellular automata. If you haven't used it much, I'm going to back up to this slide. You'll notice here what we didn't get was big streaks of water, right? So if you're just for looping through your tiles and you say, oh, I'm next to water, oh, I'm next to water, oh, I'm next to water, so you can't do that. So whenever you're doing cellular automata, just remember, I think the best way to do it for me, some people like double buffer the map, but I just go through the tiles and say, yes, you passed the test, you passed the test, and I just make a list of everyone who passed the test, and at the end I just change them all, because you don't want them to influence each other while they're testing. All right, add 3 passes of water can grow from water with a chance, and now I get these really nice lake-looking things, except they have Swiss cheese holes in them. But other than that, they look pretty good, right? So now I want to fill in the holes. So now I want to say, if you're grass and you're basically mostly surrounded by water, then fill it in, fill in the hole. So I want to be able to control how many neighbors have to be next to me. Anyone familiar with cellular automata is familiar with this part of it. So I'm going to say, and if you saw my talk before about random number ranges, anytime you put in a number, if it's plausible for it to be a number range, make it a number range. So I could make this rule be, if I have 4 neighbors, then change. But now I'm saying, if I have between 3 and 5 neighbors, change. Right? So there's a range that will qualify. So this last step here, this is spreading the water, spreading the water, spreading the water. And here this says, if I have between 4 and 8 of my 8 neighbors are water, then that means I'm basically mostly strongly touching water, so fill me in as a gap. And now the lakes get filled in, right? It's simple cellular automata stuff, but like without this chance per tile, which is amazingly something that most cellular automata doesn't have, there's so many things that you leave off the table. So there's a lot of little things like that you can do to improve some of these things that are traditional. All right, let's add another step here. This is, if I am grass and my neighbor is shallow water, change to sand. So it's another cellular automata step, but I'm now saying that the grass that's next to the water is the shoreline, and change the shoreline to sand. And that's always for everyone. So now every piece of grass that was touching water has now become sand. I'm starting to make beaches. Next step, if I'm grass and my neighbor is sand, then I change to sand as well, meaning sand is contagious over grass, but only a 25% chance. So there's going to be like about a quarter of the time, there's going to be little nubs sticking out of here, right? About a quarter of the time. I'm going to go again, and I'm going to do more of that filling in stuff. So if I'm grass and I have between 3 and 8 neighbors who are sand, then I also become sand. 100% chance, because I omit that. So obviously, when I'm adding arguments like chance per tile, I always want to think very carefully what I want the default value to be, because someone may not even know about that argument. There, so now I went out sort of sporadically, and if there were cracks, they got filled in. One more, let's create small pockets of dirt tucked into the sand nooks. So if I'm grass and I have between 5 and 8 sand neighbors, turn into dirt. So like 5 and 8, that's 1, 2, 3, 4, 5. So this guy is surrounded by at least 5 sand. That's a way for me to basically say, look, if there's any nooks and crannies, fill them in with dirt. I do another step that says, if I am grass, then there's a 1% chance to change into dirt. So now I sprinkled some extra dirt just out wherever. Here's one, and here's one. And now I'm going to say 3 times, and I can just say iterations equals 3. That's another thing that any generator can do, is how many times it wants to run in a row with the same settings. So I could have done that up here. If I'm grass and I'm next to dirt, change to dirt, 85% chance. So now the dirt spreads. And it did that 3 times, so it can spread fairly far, right? And if it gets lucky, rolls 85%, 85%, 85%, it can grow out 3. but probably only half of them are going to go that far. All right, let's add another mutator. This is a more deliberate, handcrafted algorithm piece. And what's beautiful about these mutation steps is you can have super generic stuff like cellular automata mixed with very specific things like evil temple generator, right? An evil temple generator can run before and after the cellular automata or vice versa, right? So room and path. Basic idea, let's start with, is I say rooms, there are 5 of them, and they are made out of stone floor. There you go. Okay. Oh, wait, remember any integer should be a random range if I can afford it. So I'm going to say there's going to be between 3 and 9 rooms that are made out of stone floor, but they're surrounded with stone wall. So rooms, floor, wall, these are like very hard-coded for this very specific type of mutator. If you don't want to use it, don't use it. But it's good for making rooms. All right, so now there are some number of maps of buildings. Before I had 5. Now it shows 4. It was random between 3 and 9. And it surrounded them with stone walls. All right, so now I can say, you know what, I want all the rooms to be 7 wide and 4 high, so now I can dictate how wide and high the rooms are. Apparently before, they were varying in size when I didn't specify. So what is the default argument value for width of a room? Is a random range, right? Like the default width is 3 to 8 or something like that, right? So if you support ranges, you can have defaults that also support, that have ranges. So I say, I want 7 by 4 rooms. Fine, you get 7 by 4 rooms. It's not actually what I wanted, so I go back to now manually saying, I want it between 3 and 9 wide, because I have a wide map, not a tall map, and only between 3 and 7 tall. So now I get my different sizes. Wait a minute, what happened there? There's 6 buildings. This is the same map, right? I mean, there's the water and the water. There were 4 buildings, then there were 6. What happened? Well, my procedural content generator, because I put in another step, all the random numbers are disrupted, so now it rolls a different number of rooms. Just because it has to roll room widths and heights, that might disrupt other aspects. All right, let's add another parameter, number of overlaps. So right now, you didn't know it because you were just using the simplest version, but there was a rule that said rooms can overlap 0 times, meaning it would just try to place a room and say, nope, there's already a room there. Nope, there's already a room. There's already a room. Ah, okay, I'll put it here. No overlaps allowed. And it would give up after 1,000 attempts or something like that. So if there just literally is no place for it, it won't be an infinite loop. But now I'm saying, no, you can overlap, just not too many times. So now I'm saying, and let's see, number of overlaps between 0 and 3. So that means not you can have up to 3, but each time you generate a map of this type, decide how many overlaps you will allow. And sometimes you'll decide to allow none. So now you're going to get some maps where the buildings are all distinct, but some maps where the buildings overlap. And the way the mutator is written is overlapping buildings eat each other's walls out and become these hybrid building things. There's rooms and paths, and we were only doing rooms. Let's do paths. So with some of the more complex mutators, I'll have them be elements that have child elements within them. It's really quite nice the way this generally works in code is, I call it a map generator, but in this talk I'm calling it a mutator. There's a base class, and a bunch of different mutators all derive from that base class. And so any, let's see. Effectively, any name of element that I want to support, I just put in here, and then I new off the correct generator of that, the subclass of that type. And then it goes in a chain of things that gets run. So those things then construct themselves from the XML, and they parse themselves from XML. So they can have whatever attributes they want, obviously, but they can also have arbitrarily complex nested data structures, including, by the way, in this game, the actors have different behaviors, and the different behaviors have different utility formulas that decide how much they want to do those behaviors, and they have parameters like for wander, how far they're going to wander. And I can even put those things in here. I can say certain types of rooms give behaviors to actors, which I'll talk about in the last talk of the day. Anyway, let's go back to rooms and paths. So we added paths, and what did we say? We just said paths floor equals rough floor. So whatever paths do by default, let's let them do that. There you go. There's a path here and a path here, and apparently it eats through the wall when it's drilling into another room. The way I wrote this, just as a simple example, was just go through the rooms in random order and chain a path from this one to this one, and then this one to the next one, and this one to this one, and this one to the next one. So it makes a chain. All right. Those paths are pretty crooked, though. I want this to feel like a town, like some of those were intentional streets. So maybe the paths has a chance to be straight, right? You can have straight paths or not straight paths. Or maybe straightness is something that affects the path during generation. So if I say I want them to be 100% chance to be straight, then now I get all straight paths, right? All right, so let's say I now want to say I have a 70% chance of being straight, so they're sort of mostly straight, but then there are a few, statistically about a third of them or so, that are going to be non-straight paths. There are far more interesting ways to parameterize this. This was like me hacking this demo together. All right, so I've done my rooms and paths. Now is where it gets interesting, because I can go back to my cellular automata and do another round of that, right? There's no reason I can't do some rooms, then cellular automata, then more rooms, then more cellular automata. This is really great for doing things like erosion or ruins, right? Where you want to make a building and then like mess with it. Okay, so here I'm going to say, if I'm water and all 8 of my neighbors are also water, then I become deep water. So now I get deep water in the midst of my shallow water pools. So anywhere that's like totally in water is now considered deep water. Maybe that's just an aesthetic thing, or maybe that's where the sharks live. All right, now one of the things that I'm noticing that looks a little strange is, let's see. Wait, didn't I just do that? Oh, okay. That's what the step is. So here I said, after you've done everything, change shallow water to deep water. Well, you'll notice now that these sort of bridges, I guess you would call them, the walkways, they are causing shallow water to be near them, right? Because they're no longer surrounded by water, because they're touching the walkway. So anywhere where a piece of content sort of sticks out into the water ruins the deepness part of it. And that's fine. Maybe that's what I want, right? Maybe I want this to be like an embankment that someone built up, like a levee or something. But if I don't want that, I can take this shallow water and move it earlier in the cycle. So now I'm going to change shallow water to deep water before I made all the buildings, so that the deep water will exist and then the buildings will go over it. Right? So now we get the deep water whether the buildings and the roads are there or not, and the roads just go over the deep water. So one of the issues with these kinds of systems, I mean, I still data drive it even if it's just me as the client. But if you're expecting a designer who's not a programmer to be playing with these kinds of systems, then they typically need to be fairly technically minded. And one of the things you're going to want to do is really, really, really help them understand, hey, if you do this first, then do this second, then do this third, see how it can do this, or do it in the other way. And probably most designers will intuit, yes, I see that it did that before the other thing. But they may not think of, oh, gee, I can put my roads before the water or after the water to have this effect or that effect. So one of the things I found is really important when working with artists and designers is give them not just hello world examples, give them actual cool, full-fledged examples that show different techniques and their ramifications. All right, so now we have Roads that go over deep water, great. Now I'm going to write these two rules down here at the bottom. This is paths become bridges when adjacent to water. So if I am rough floor, which is what this stuff is, this is all just rough floor, and I have between 3 and 8 neighbors of shallow water, then change me to a shallow bridge. Like it's a bridge I can walk over, but it's over shallow water. It's a tile type I have. But if I am touching any amount of deep water, then change me to a deep water bridge. So now these roads become bridges. And the bridges over deep water have the deep water color to them, and the bridges over shallow water have the shallow water color to them. And by the way, this is, oops, I'm not actually playing. That's why I can't. Hold on a sec. Wait, which one was this? Anyway, and obviously I'm actually changing tile types, so it changes the physics, et cetera, et cetera. So these are actually diversible tiles. Because I actually pathed from the one room to the other, I know that the paths are still connected. I'm just changing them cosmetically. All right, now let's go back for a minute. So this is a lot of friggin' water and chaos all over the place. This is an absolute disaster. So I want to tone it down a little bit. So I'm going to go back and say, that initial piece of water, which I think I had at, it's off screen, but maybe 1%, I think. I'm going to change it to 0.1%, like 1 in 1,000 is water. So now I only have 2 seeds of water, but all that other stuff is still happening, right? So I can easily go back at any point in my algorithm and mess with it and get very interesting different results. And all this work I did with sand and with deep water and dirt remains. And I can still play with how much water I want just by changing that one knob of the water. All right, we already saw iterations. So that's just how many times I want to run something. So this, if I start with shallow water, just only 1/10 of 1%, instead of 4 times, 3 or 4 times, I'm now going to 8 times let the water spread out and be contagious. So now I have fewer, bigger lakes. Right? Just by changing the number of iterations and the number of seeds of droplets of water. All those can be random ranges. All right, so the number of iterations can be between 3 and 10. So now if on one map I generate, it will say, oh, let's only do 3 iterations of this. And so that'll only spread the water a little bit. On another one, it'll say, oh, let's do 8 iterations of this, and it'll spread the water a lot. So now with the same logic, here I get these 3 little ponds versus 2 massive ponds, really 2.5 massive ponds versus 1 large pond, right? Just same data with different random ranges. All right, next mutator, from file. This is just content injection, like we said before. So here, I just say from file equals throne room. And boom, it's going to pull that file from disk. And this is the throne room. It's awesome. I made it. And it's just going to inject that into the map at that stage in the process. You'll notice I put it after the rooms and paths, but I put it before the shallow water and the deep water stuff. So the throne room will still, if it lays any walkways, they'll still be turned into bridges, I guess is what that is. All right. However, if I put the throne room in, it's just going to actually slap it on the level itself at 0, 0 position. That's probably not a good default. I should probably change the system to say that it's going to place it in a random position by default. So I should change that. But I can position it manually. I can say offset equals 25 to the right and 7 up. So I want it to be in the center of this map. And in other versions of this, I would more typically have the maps be dimensionless, and I would give those in terms of normalized coordinates, 0.5 being in the middle, kind of like UVs, right? So 0.5 would be put it in the middle-ish. I can do other stuff to my data. I don't have to just take it as is. I can say I want it to be 20 to 30 to the right, 4 to 10 up, and I want it to be rotated 1 time. These are tiles, so I'm just going to do a 90-degree rotation, but obviously in a free geometry world, I could rotate it however I want, maybe even in 3D. So now I've rotated it once, and I've put it somewhere in the middle, but not quite in the middle. I guess I need to hurry up. I can also say number of rotations. Why not? It's an integer range between 0 and 3. That gives me all 4 orientations. So I can now be in any orientation, just somewhere in the map. Or I can say equals 0 or equals 3 if I want a specific orientation. Lastly, I'm not sure if it's lastly, I have a chance to run on any step. So every single step is optional. So one time you go and run this village, from file is going to say, nope, I'm not going to add a throne room. And the next time it's going to come through and say, oh, yep, I guess I will add a throne room. Right, so now I'm going to get maps with throne rooms and maps without throne rooms. And I can easily have any part of this be optional. I could have even the sprinkling of water be optional, right? So there just is none. I can put a chance to run on my grass turning into, grass next to neighbor turns into dirt. So now I'm going to get half my maps that have, that turns into sand. So half my maps get sandy beaches and half of them don't. Right? Lastly, I could have a mutator Perlin noise, for example. So if you're familiar with Perlin noise, if you're not, you're going to get plenty of it for the rest of the afternoon. But that's a random noise function from -1 to 1, kind of like the sine wave, but like weird. And I can say if I'm grass, and there's some weird invisible noise function that's going from -1 to 1, and if my noise value is between 0.4 and 1, then change to shallow water. And notice this is test 2 now, so this is I started over with a completely new map type. And so I get this. This is what Perlin noise looks like in a simple way. I can also control the various variables of Perlin noise, which we'll see in one of the next talks. I can choose the grid of the Perlin noise, how often it repeats. It doesn't actually repeat, how often it cycles. And how many different sub-noises stacked on sub-noises stacked on sub-noises. It's the harmonics or the octaves that are added to the Perlin noise. So now just by saying I want grid sizes between small and large, and I want between boring noise versus noise with 2 harmonics or 3 harmonics added to it, I can just, with those simple parameters, get this is really big grid with only 1 octave. This is maybe a smaller grid with multiple octaves, so I can get a lot of variety. And Perlin noise always gives these beautiful organic-looking shapes. And then here's one I just made called Island Palace, where I just said, throw 50 rooms on top of each other. They can overlap as much as they want. It defaults to water surrounded by stone. Oh, and then put in these like lava pool gardens because it's an evil person. I don't know. And there's a 50% chance of a throne room, whatever. So there you go. That's a totally radically different feel of a map than this, right? And it's all using these exact same totally simple tools. So for all mutator steps, I always say they can run or not. They can run so many times. I actually don't have a Perlin noise generator step. I now say any step can also have to pass an if Perlin test. So do your cellular automata, but only if you're within this Perlin noise threshold. So like you can get blobs of where it does the cellular automata, or blobs of where it adds the from file. Only parts of the building and not others. I can even add patterns, like I can define different patterns, checkerboard or like fishbone pattern. And I can say if I'm one of the even tiles in the pattern, then I'm going to turn into this, or I'm going to do this other thing, or I'm going to replace. Or if I'm part of the odd parity of the herringbone pattern, then I'm not going to do the thing. We're going to talk in the last talk about adding tags, unchecking tags, adding levels of permanence. So you can write a building and say, this is permanent. Whatever you do, don't mess with it. Or this is fairly permanent. I could make stuff that's conditional, like, well, only add the water if we're in a wet biome, right? Don't add it in the desert. Or we'll start our thing with sand instead of something else if we are in the desert. And again, I'll tell you more ideas of that in the last session. So you can easily do stuff like moss that grows on the north sides of buildings. You could have cellular automata rules that are directional. Tile sets that swap in. So you have like tile sets that have corners that are rounded, when they go around the corner at the shoreline, you can swap those nice tiles in, just all with the same thing. You can have buildings, and then you have a random chance to change the stone into gravel, so they're partially crumbled. You can have translucent alpha in your source buildings. I don't have time to show it, but mine buildings are just images, and if I have alpha transparency, then that means when I drop the template in, don't disturb those tiles, right? So there's space around my building. But if I'm 50% alpha, that means 50% chance of disturbing those tiles. So the artist can actually paint probability into the data that comes across. Rivers that flow, drunkards and worms. That's our next session, digging with Perlin worms. Summary, why write generators when you write mutators? Create your content in stages. Humans author the definitions. The definitions invoke the stages. The stages are highly parameterized. They expose lots of knobs, and they need reasonable default values because mostly you're not going to be messing with those knobs. And you can get endless combinations. This is just the tip of the iceberg, just with a few mutators. And each one you add has like an exponential effect on all the things people can do with it. Give your designers not just bad programmer hello world examples, but really cool examples that actually give them ideas, not just like API documentation sense of how the system works. Thank you very much.